What's happening? So this will be a very short, straight to the point, I hope, tutorial on gas density and converting between molar mass and density and molar mass. I have attached 3 questions that I plan to be my practice problems, but I can't get to those until I go over some background information. So how you want to organize that is kind of up to you. What I'm going to do is scroll down below the 3rd question and begin taking notes here and then go back up, all right? So note that whenever we talk about density, we are talking about a mass per, the line means per, all right, unit volume. Now, typically, if we are dealing with solids or liquids, we have grams per milliliters as our density unit, all right? Recall that 1 milliliter is equal to 1 centimeter cubed. So we could also say that this is in centimeters cubed. Sometimes we get the volume doing a length times width times height, okay? We are going to be concerned with the density of gases, all right? And because gases spread to fill their containers, their volume is going to be much greater than a solid or a liquid. So milliliters is not going to suffice. So we will have grams per liters, okay? So with gases, our density unit is in standard grams per liters, whereas the solids or liquids, we have grams per milliliters because they take up much less space. Okay, good. Now there is another, remember that at STP, we know that 1 mole is equal to 22.4 liters, or 22.4 liters is equal to 1 mole, okay? We also know that, that's it. So let's start looking at how this could come at us. First of all, let's go up here. Let's look at a problem. What is the molar mass? Okay, now that was the other thing I wanted to say. Let's go back down here. Molar mass, right? And I want you to think about it. What are the units for molar mass? They are grams per mole. So we have grams per mole, right? So when you're asked to solve for the molar mass, you need to take the grams of the substance, right, and divide it by the moles of the substance. And that will be your molar mass. Okay, let's look at our problem. So it says, what is the molar mass? So what we need in order to get the molar mass is to get the mass of the gas, and we need to divide it by the volume. Nope, molar mass by the moles of the gas. Okay, so in order to solve this problem, I know that I need the mass of the gas and I need the moles of the gas. Okay, well, let's look over here. What I am given, we need to fix this problem and we need to clarify that we are at STP. Okay, so your problems on CK-12 are all considered to be at STP as well. And what that means is that 1 mole of the gas is equivalent to 22.4 liters of gas. Okay, organize your data. Or 22.4 liters is equivalent to 1 mole. Okay? Now, so what we need, once again, is we need the mass and we need the moles. We know that 1 mole is equal to 22.4 liters. We also know that we have a density of 2.18 grams per liter. So there's 2.18 grams of gas for every 1 liter of gas, or every 1 liter of gas is 2.18 grams. Okay? So we are left to assume that we have 1 liter of the gas, right? Therefore, we have 2.18 grams of the gas, right? So let's look at that. Let me write that out. Right, we have 2.18 grams for every 1 liter. Well, let's look at this, guys. Can't we multiply that by our molar volume? And see that there's 22.4 liters in every 1 mole. And see that my liters will cancel, and I'm left with grams per mole. And I see that if I divide that or multiply my density, right? I'm essentially multiplying my density times the molar volume, and I get 48.8, grams per mole. That is a molar mass, right? A molar mass. And we know it's a molar mass because of the units. The units are grams per mole. That is a molar mass unit. All right? So essentially, notice that I took my density and multiplied it by the molar volume, and I ended up with the molar mass. Now, what does that tell me? That tells me as the density goes up, the molar mass goes up. Or as the molar mass goes up, the density is going to go up. So I see a direct relationship there. All right, let's look at this one. Once again, what is the molar mass? So we need number of grams divided by number of moles. Okay? And we have 8.20 grams. And let me tell you this. Look, we have 6.25 decimeters cubed. Well, let's go back up here. Let's go down here rather to our notes. Just like 1 milliliter is 1 centimeter cubed, 1 liter is equal to 1 decimeter cubed. Okay? So when we go to our second problem, and we have 6.25 decimeters cubed, that is 6.25 liters. What is the molar mass? Once again, we are left to assume that this is at STP. Therefore, we also know that 1 mole is equivalent to 22.4 liters, or 22.4 liters is equivalent to 1 mole. All right, now I've got a mass of a gas in a given volume of gas. So I could use that to get my density. In order to get my answer, I need to know my mass of gas. I have it. and I need to know the number of moles of gas. Well, if I have 6.25 liters, and every 22.4 liters is 1 mole, then if I take clear 6.25 and divide it by 22.4, I get 0.279 moles, right? So that is my number of moles, and I can divide my mass by my number of moles. And when I do that, I'm dividing a grams by moles. My unit is 29.4 grams per mole. That's my answer. I could have done this another way. It asked for my molar mass. Right up here, we said that the density times the molar volume equals the molar mass. Well, the density is found by taking the grams and dividing it by the liters and multiplying it by the molar volume. The molar volume. Whoa. You see what I did wrong. It's 20. I was looking at my units and figured out that 22.4 liters per mole, right? As a matter of fact, let me write it like this so that you can see your units better, right? Here my liters cancel. I'm left with grams per mole. So I have 8.2 divided by 6.25 equals times 22.4 equals, and once again, I've got 29.4, same answer. And that's my molar mass. Let's look at one more together. What is the density? So that means I need the mass in grams divided by the volume in liters of a gas that has a molar mass, and this is at STP, right? So I'd have 70.9 grams per 1 mole, and I know that 22.4 liters is 1 mole. And I need a mass over a volume. Okay. Well, let's assume a volume of 1.0 liters. Because my density says, because my molar volume says that if I have 1 mole, or actually, let's assume that we have 1 mole of gas. Right? Because, oops, there's not 2 S's there. Because I'm making this hard. Because 1 mole equals 70.9 grams, and 1 mole equals 22.4 liters. And if I divide 70.9 divided by 22.4 liters, what do you get? 3.16 grams per liter. Okay, and so it's a manipulating units game. And if you enjoy manipulating units, it's good. If not, it gets tricky.